Hello, we're gonna go ahead and solve this LeetCode problem here since I had some time to do so. So the problem is from the website NeetCode, which is essentially just a variation of a LeetCode problem. So the problem says it's a longest repeating character replacement, and it's given to us in the section of the actual window technique. So we need to use a window in between these strings to figure out how we're going to meet the conditions. So it's called specifically a sliding window. There's different types of window techniques, but this one is called sliding window. So that's what we're going to try to use to solve it. And we're going to try to do it in O of n time. So it's fast. So it says you're given a string consisting of uppercase English characters and an integer k. You can choose up to k characters of the string and replace them with any other uppercase English character. After performing at most k replacements, return the length of the longest substring, which contains only one distinct character. So essentially, all it's saying is get the longest possible substring of the entire string. So everything in between quotations is a string, and a substring is anything that's in there, a combination of things like AA or three A's or three A's and a B, or all of them except for this B, etc. So it's just all the permutations that you can make out of it. But specifically in this problem, they want the specific case where we can get the most amount of characters possible. So the most amount of B's or the most amount of A's, whichever one is greater. But keep in mind that for other tests, they won't be as simple as this. You'll have like, I don't know, 20 different characters, and you have to figure out which one would have the best number that we want, sort of the greatest number of a single character. And also, you have to account for the fact that even though you may turn this into an A since our K is 1, and now we have 4, we can't miss this fifth one here because we don't have to switch character for it. So this would be the optimal solution would be 5 because you have 3 A's and we turn this B into a 1, and then you have to account for the 1 after the B. In my opinion, that's the only challenging part of this problem. So that you have to account for the letter after that 1B. Otherwise, it would be a lot easier to do. So to actually work this problem, we're going to use hash map just to keep track of like the count. And I'm just going to call it M for map, I guess. But to make it more significant, I'm going to put count. I'm going to create some variables. This is going to be our answer, which is result. It's going to be a left pointer. And then max frequencies. And they are all integers. Then we go right into the main loop. So we're already going to start the logic. All right. So what's going to happen here is we're going to start our sliding window. And the window needs to meet the condition. Essentially, we're going to create like a math condition in where whenever we have a string in which we used up all our k's, then we're going to move the window. So whatever string we get to that uses all our Ks, then that's going to be our max answer. And we're going to check every answer afterwards. But we're going to take advantage of the fact that if we find an answer early, we can skip over needless iterations. Like if we find, for example, here 5 items that match A, we don't want to waste time and try to check variations that'll give us less than 5. And to do that, we are just going to not allow max frequencies to decrease. So this can only increase. Max frequencies will never be decreased. It can only ever increase. That's going to be what helps us with that. So that's our hash map, which is count. And into our hash map, we are going to insert a character. So that character is going to be the current instance. Oops. The current instance that is R. So here all we're saying is into our hash map. So pretend this is the hash map. We're going to say into our hash map, insert our character. So let's say it's the letter A, for example. And that's going to be our actual value. And the key is going to be the number of times that it appears. So let's say it appears 2 times. Then you should have 2. Each plus plus will increment this once. So obviously it starts at 0 by default. But once we do plus plus, it's going to be 1. And if we encounter another A, then it's going to turn into a 2, etc. Right? So it's just going to be increasing every single time that we hit this plus plus for that character in the string. And then we're going to say max frequencies. And we're going to take the maximum possible, whether it's a new maximum or whether it's the current maximum. So this is the current maximum. And this will account for the case to see if it's like a new maximum. So here, like I said, this will be just a helper. And then we can get into our while loop. So I'm going to say right, which is our loop controlling variable. So right minus left, which will give you the window that you're currently at. But since it's a 0-based index, as you can see, we start to 0 and we go all the way less than size, not equal to size, but less than size, strictly less than size. So if it's, let's say the size is 5, for example. If the size is 5, you're going to go 0, you're going to iterate through 0, 1, 2, 3, 4, and that's it. That's 5 numbers because you're including 0. 0 is a number, 1's a number, 2's a number, 3's a number, 4's a number. That's 5 items, and the size is 5. So you're going through the entire string anyways. But we want the actual, the window. So I'm adding 1 just to that so that we can get the actual window. To account for the 0, basically. Okay, so we're going to subtract max frequencies from it, and we're going to make sure that it's strictly greater than k. We can also do like less than or equal to k, but I mean, it'll give us the same answer. And in here, we're going to go ahead and do count. And we're going to decrement it when we can meet that condition. Since we're taking our leftmost item out of the window, we're decreasing this since we don't need to account for it anymore. And here we're going to decrement, we're going to increment our left to move it forward, which will shorten our current window, technically. And here we're just going to take the max of itself or the window that we're in, like the window size, just like we did up here. So all this does is it gets us our window size. And that's it, basically. And I'm pretty sure this works. Let's see if we get any errors. Okay, it says L was not declared in the scope. That's because I put semicolons instead of commas. It's just a syntax error. All right, looks like it's working as expected here. And we got it. Okay, great. So it looks like it's done. So it's that simple. Um, like I said, we used a sliding window to figure out how many characters we could fit into a substring derived from the entire string. And we used k equals 1 to change a specific character in that string in order to maximize our substring without repeating any character. And that was it. So thank you.